Hi guys, for the first part of the plane geometry for the Elite Hard MC problem, part 1, I'm gonna go through a few questions from those past paper. So let's have a revision again. We have the similar figure, then the area ratio would be the length square to length square. And if we have a same base or same height problem, then the area will be directly the ratio for the base or for the height. Okay, and then for this part is in the S3 chapter 8 for the late part. Okay, so part 1. In the figure, there are two rectangles with the same parameter. So they have a really key point for the same parameter. And then the ratio of AB to BC would be 3 to 2, and then PQ to QR would be 4 to 3. So may I know, can I just leave the length like this, like 3 to 2, 3 and 2, and also 3 and 4? No. So we need to make a ratio. So we have a 2x and 2x, 3x and 2x, and also 4y and 3y. So at the end, we want to find the area out for the ratio. So for the area will be base times height for rectangle. So 3 times 2, 3x times 2x would be actually 6x squared. And then 4y times 3y actually means 12y squared. However, our ratio cannot be identified by sum of the x and sum of the y, but there is one more information that we haven't used. That would be the same equal parameter. So it means parameter for the left one would be 2 times 2x plus 3x. And then the other one would be 2 times 3y plus 4y. They have the same parameter. And then actually we can solve them. Then it means 5x equals to 7y. So x to y, it means 7 over 5. And for our area ratio of the area, what we are trying to find would be 6x squared over 12y squared. Then it means 6 over 12 and then x over y to the power square. So that means 1 over 2, and I try to substitute the 7 over 5 for x over y. So it actually means 7 over 5 and then square. Then the final answer by calculator, then that means 49 over 50. The answer would be D. Okay, so question number 2. In this figure, it is a parallelogram, and then E is a point on AD, such that would be 1 to 3 for the ratio. So that would be 1 to 3. Find if the area of triangle ABE, this one would be 3 cm square. So may I know what about the shaded region? In this question, for the 3 cm square, they actually imply a lot. If we have AE as a base, and then I can look for the height, and the height this time would be from the E, drop it over to BC perpendicularly. That is actually the height. It is the h. So it basically means 1 times h over 2, then it means the 3 cm square. So h in this case would be 6. So if we can find the height already, then we can also find the shaded region. Then in this region, then it means in total we have got 1 and 3. Then add them up, become BC. Then it means 4. So if we want to find out this trapezium area, because it's a parallelogram, right? It's a trapezium. So upper base plus lower base times the height would be 6 divided by 2. Then in this case, we have got 7 times 6 over 2. Then it means answer C. So it's actually a trapezium, and area of this trapezium. Okay, question number 3. Line ABC. So this one is in the S3 chapter 8 at the end. Okay, so AB would be 8 cm, BC would be 4 cm, CD would be 9 cm. Please find out BE for your final answer. So we are using the ratio that would be similar figure, so 8 over the entire length, 8 plus 4, and then equals to BE over 9. Then it means BE we can solve by 6 cm, then answer D. Question number 4. In this question, we have got some ratio as well. That would be 2 to 3 for the ratio, and for the other one, that would be 1 to 5. Okay, and so please at the end find out the ratio for OA to AB. Okay, so first of all, if we want to find it out, and then we try to let H for this ratio, and that is our final target, right? Okay, so it means the length for the small triangle to the larger triangle, if we look at these two ratio, then we can find out that H is the yellow one to the entire one, H plus 2 plus 3, then it means the shorter one, 1 to 5. Then if we can build this equation up, then we can solve H. So H would be 5 over 4. After we solve them, we know H will be 5 over 4. Then to the other ratio AB to 2, then it actually means both of them try to times 4. So it means 5 to 8, then answer would be C. We're using similar figure for that, for the ratio. Question number 5, it is quite hard problem. And in this case, we might need to add some different line as well. So in question number 5, ABCD is a parallelogram, and M is a point on BC such that MB to MC would be 1 to 2. If BD and AM intersect at G and the area would be 1 cm square, please find the area for ABCD, the entire parallelogram area. Okay, so in this case, from the previous the concept, we saw very familiar for having this shape. Is the first part very familiar? The first part here is the one that we gone through before, and it is similar type. So why is it similar? Because the parallelogram in total length, they are opposite side, right? So if it is 1 to 2, then add them up. Actually, this ratio would be 3. Since we have a similar triangle, so this one and this one for the similar figure, and then we can look for that would be 9 cm square. Why? Because 1 over 3 at the end, we are looking for area, then it means 1 cm square to triangle AGD area. Okay, then it means 9 actually. Okay, so if we can look for 1 to 3 would be the ratio for the length, then this one means 3 for the ratio, and this one would be 1. And if I look like this for this type, if this area is 1 cm square, and then the base here, the length ratio would be 3 and also 1, then we have got the same height. So I'm trying to look at ABM for this triangle. Okay, and then if their height is the same and we have got a different base, so the ratio of area would be the same as the base. So that means 3 cm square. If this one is 3 cm square, then the opposite triangle will be also 3 cm square. Then at the end, I need one more triangle, and I have got a same height as well. So if I look at this triangle and this triangle as well, in total here will be 4. We have got a same height but different base. Where is the height? The height is here. They have got the same height again. Okay, and I would say if this one is 1:2 ratio, then it means 4 to something. So that means 8. Then in this whole area, that would be 8. So at the end, you can add them all up by having 1 plus 3 plus 3 plus 8 plus 9. Then final answer is D. Okay, so that is the first part for the worksheet for question number 1 to 5 for those hard problems. Let me have a quick review. What we are doing today is, first part we are talking about the rectangle, and then it's the simple type for having equal parameter and find the ratio. And then the second part here, what we have gone through would be the same base, same height problem. So it's like type 2 for the same base, same height problem, okay? Same height problem. And then question number 3 is from the similar triangle, and then we find out the length ratio, and then by corresponding size, and then congruent triangle, a similar triangle. Okay, and then the upper one as well. For number 4 is also the similar triangle by putting the smiley face for the corresponding size as well. Number 5 is a mixed type. We have got a same base, same height problem, but also we got a similar triangle as well. So 2 type in total. So it's like a type 1 and type 2 by a mix. So it's quite hard. So that's it for the question number 1 to 5 for the review, and I hope you enjoy, and then try to stay faster and try to be familiar with the type as well. Thank you.